Hello students, so this is our third lecture on graphical analysis of motion. So first of all, in this third lecture we are going to start basically speed time and velocity time graphs. So we are going to start with velocity time and then we are going to do speed time, and then after that we are going to compare the two kinds of graphs. Okay. So first topic over here is velocity time graph. So please write down the heading. Velocity time graphs. I'll be starting with very simple types of graphs so that you find no problems in understanding. So firstly, if somewhere it is mentioned that the velocity is not changing with time. Okay, if somewhere it is mentioned that the velocity is not changing with time, that is, we can say this as uniform velocity, uniform non-zero velocity. So that will be like this. So velocity on y-axis, time on x-axis, it will go straight like this. This is uniform non-zero velocity. So uniform velocity means velocity is not changing with time. So I think this is very easy to understand. Now, if there is uniformly increasing velocity, uniformly increasing velocity, uniformly increasing velocity, so if it is uniformly increasing velocity, that means the graph may go like this. It will have a positive slope. It will have a positive slope with the x-axis. It will have a positive slope with the x-axis. That is uniformly increasing velocity. I think it is clear. Now it can happen that the body is starting from rest in this only. If the body is starting from rest, body is starting from rest, then basically the initial velocity will be 0. So that is why it will start from origin. So body, if starting from rest, it will start from origin. In this case, the body is not starting from rest. It is starting with some negative velocity over here. And then the velocity is becoming positive. Let us understand the physical significance of this graph first. So if you see this graph over here, so from here to here, there is a negative velocity. What does this really mean? If this is the observation point, first the body is going in this direction. So if I take this direction as positive, so this displacement will be negative. Okay. And after that, the body is traveling in the positive direction. Okay. First it's traveling in the negative direction, and after that the body is traveling in the positive direction. However, you need to understand here the velocity is continuously increasing. Here the velocity is continuously increasing. That is, the velocity is going from negative to positive. Now how this is possible? How this is possible, you need to understand this. So this is a little critical one. That is why I took this. So I am going to explain it over here step by step. First of all, velocity is say minus 5 meter per second. Okay, minus 5 meter per second. Now if this is the observer point, if this is the observer point, then definitely as the velocity is negative, first it is going in this side. First it is going in this side. So that is why the velocity is negative. So now if you see this, let's take this as minus 5. In this position it will be minus 3, and here it will be 0, right? So it was going initially it was going at minus 5 meter per second. Then after some time it becomes minus 3 meter per second, and the body comes to rest. Body comes to rest after some time, that is 0 meter per second. This is this point. The body is at rest. Okay, and after that the body rebounds, or the body changes its direction, starts traveling with an increasing speed. With an increasing speed, it starts traveling, and here is that part of the graph where the body is traveling with increasing speed. Okay, clear? See, the understanding has to be like this way only. It has to be mathematical and also be related with the actual phenomena. That is how physics should be studied, and that is what we are doing in this Foundation Class 9 course. Clear? So it is becoming positive. So originally, if you see this part to this part, I am talking about this part, basically this part, there has been a retardation, right? The retardation is in opposite direction, because you see the magnitude of the velocity has decreased. So there has been retardation over here. There has been retardation. The magnitude of the velocity has been decreased. So there has been retardation. After this, if you see this part, here the magnitude of velocity may have increased from 1 meter per second to 2, 3, 4, 5. And we can see an increasing curve over here like this. So here there is guaranteed acceleration, right? Here there is retardation. Clear? Okay, coming to the next point. This was very interesting, I suppose. Now let us take a speed time graph. Again, interesting. We are taking one speed time graph. Okay. So again, I'll first draw the curve over here. See this. So definitely from say 0 second to 5 second, the speed has decreased. 0 second, 0 to 5 second, speed has decreased. So here the speed has decreased, that means there has been retardation. Okay, and then from 5 seconds to say this as 20 second, the speed has increased. Speed has increased. So here there is acceleration. Here there is acceleration. Here the speed has decreased and then the speed has increased. So if you say that this is same as this one, this may not be true. This one may not be same as this one. Maybe, may not be, because here also the speed has decreased, became 0, and then it has increased. Okay, but here it is not so, because the problem is speed doesn't show any direction. So you cannot say whether it's minus or plus. So if we cannot say whether it is minus or plus, we cannot really give a conclusion that it has traveled in opposite direction. It may happen that a car is traveling in this direction. Okay, a car is traveling in this direction with initial velocity as say 5 meter per second. Now there is a retardation and the final velocity say v1 became 0 meter per second. And then in the same direction, it moves in the same direction and it increases to 20 meter per second. Okay, so it is first it is a retardation, then it is a acceleration. There is no guarantee that it will have a negative side movement. It may have a positive side movement, but when you see this graph, we are 100% sure that there will be a negative side movement. Okay, this is 100% sure. You cannot ignore this, because there has been a negative side movement in this one, right? So here we are sure that it has moved negative side and then it is going to the positive side. But here it may not be so. It may also be so. It may not have negative side displacement. Okay, clear? So you have to keep all these things in mind, how this okay. Now let us go for the next question, or next graph rather. What about this? Velocity time. This one. This one. Okay. So we need to find out this. What kind of graph is this? Definitely, if you see here, the slope is increasing. Here the slope is decreasing. How will you understand that the slope will increase or decrease? Very simple. If it is going towards the x-axis, if you see this graph is going towards the y-axis, then the slope will increase. It is going towards the x-axis, so slope will decrease. So as slope decreases over here, so acceleration decreases. Acceleration increases. Clear? So this is what it is. Very simple. If somebody gives you this one, what does this mean? This means acceleration is constant. But as the line is coming like this, that means velocity is decreasing with time. That means the slope here is negative. So here the acceleration is negative, which essentially means it is a retarded body. It is a case of retardation. Correct? Clear? It is a case of retardation. It started with say 5 meter per second. It becomes 0 meter per second. It may go this way also. It may go to negative direction. Negative direction. First it is going positive direction, then it is going in the negative direction. It is possible, right? If it is like this. Clear? Now suppose first the velocity in positive direction, then it is negative direction. If I want to convert this into speed time graph, how will I go about it? See, the positive part remains same, so I'll just draw the same thing over here. This doesn't change. After that, the velocity increases in the negative direction. Negative part will not come, it will go like this. So when you have to convert like this. Okay? I'll try to draw a very beautiful curve and we'll analyze the motion. Here the speed is increasing with time. But if you see, the rate of increase of speed has decreased. That means here the slope is decreasing. Here the slope is increasing. So you can say easily that this part is decreasing acceleration, this part is increasing acceleration. Now if I say you to convert this into, yes, you got me right, velocity time graph. Can we do that? Definitely we can, right? So first of all, here acceleration decreases. That means the first part is same, like this. And then we really don't know what exactly happened over here. Why? Because one case can be after the acceleration has decreased, here it is said that the slope is increasing. The acceleration has increased. The speed may increase. The speed may increase if the acceleration has increased. Okay? What about velocity? What about velocity? Well, it may have same kind of graph if it is in the same direction. Suppose it is not in the same direction, then if after this it tries to move in the opposite direction, then what happens? Then what happens? The velocity becomes or comes under, velocity comes under what? Comes under negative direction. Now how do I show that in my graph? So here if it travels in same direction, what about the other part? It may not travel in the same direction also. It is absolutely possible. It may start traveling in the opposite direction altogether. Then what happens? This is okay. After that, now it is traveling in the opposite direction. That means velocity at this point of time, see, will become directly negative. Will become directly negative. But the question is, sir, whether it is going to have a zero velocity or not. Definitely it is going to have a zero velocity directly over here. It will come like this. Because it's like this. Body is traveling like this. It has to have a zero velocity over here, and then it goes come like that. Now what happens? Now if you see, the speed is increasing. Speed is increasing means the magnitude of the velocity is basically increasing. Magnitude of the velocity is basically increasing, correct? Okay, so we don't know where from it exactly starts. So I'll start from here. So from here onwards, the magnitude of the velocity starts increasing with time. So how can I show that? I will show that like this. See, the magnitude of the velocity is increasing with time, right? So this is when it travels in opposite direction. If it travels in. So as you can see, we are going into deep and deep into the system now. And that is what we intend to do in this foundation classes, so that you have an ability to think intense, think deep, and this is a development phase basically. So everybody of us should struggle over here, and after the struggle, when you face the struggle again, then the same struggle again, the struggle becomes easy, the war becomes easy, because you have fought those wars earlier. That's what it is about life. The first war is always difficult, and things get smoothen out when you do it again and again and again. Okay, so that is the end of graphical analysis part in physics completely. So you will be able to do all the problems mentioned in your modules based on this whatever is taught on graphical analysis, and we'll definitely have some live doubt clearing sessions after this, so that in case of any doubts, we are going to solve it and go ahead together. So thank you guys. Thank you everybody.